Okay, we are going to work on the review for the Geometry Unit 7 test over circles. So to start with number 1, we are supposed to find the measure of the angle marked 1. As you can see, it says to the right that A and B are points of tangency, so these lines that extend or raise technically are tangent to our circle, which means if I draw the radius on here, like so, from point O to point A, this is going to form a 90-degree angle. Also, I can draw a radius from point O to B and make another 90-degree angle. So now I have created a kite because both the radii are the same and the tangent segments are the same. This kite, as any quadrilateral, will add up, all the 4 angles will add up to 360 degrees. So, since I know that the arc from A to C to B is 240 degrees, it says so right over here, and I remembered that a whole circle is 360 degrees. If I subtract out the 240, that leaves me with 120 for the arc on this side. Now, the central angle has the same measure as its intercepted arc. So that means that the 90-degree angle, the 120-degree angle, the other 90-degree angle, and angle 1 should add up to 360. So I'm going to add 120 plus 90 plus 90 to get a total of 300 degrees. So that's what the 3 that we know are. To get the measure of angle 1, I'm going to go 360 minus 300, which is, of course, 60 degrees. So the measure of angle 1 is 60 degrees, and the measure of arc AB, we have already figured out here, is 120 degrees. All right, for problem number 2. I can see on problem number 2 that I need to find the measure of angle 1. Angle 1 is what we call an inscribed angle because its vertex lies on the circle and the arc that it intercepts is 140 degrees. So we have a conjecture that states the inscribed angle is half of its intercepted arc. So half of 140, or 140 divided by 2, will give us an angle measurement of 70 degrees for angle 1. Now, angle 2 is also an intercepted arc, just like the other one was, and it intercepts the arc measuring, it's an inscribed angle, I'm sorry. Inscribed angle, it intercepts the arc measuring 160 degrees. So I take 160, divide it by 2, that gives me angle 2 is 80 degrees. And last, I need to find the measure of angle 1. Since I have a triangle, all triangles add up to 180. I can take 70 plus 80, which gives me 150. And then 180 minus 150 gives me 30 degrees for angle 3. Okay. Problem number 3 is trying to find the measurement for angle BAC, which is this one that I just marked with a green X right here. AC is a diameter of the circle, and this angle that is marked 42 degrees will add with the angle from A to the center to B to equal 180 because I have a straight line there. So I'm going to take 180 minus 42 to get the measurement for the obtuse angle adjacent to it. So that's going to give me 138 degrees for this obtuse angle. This triangle is isosceles because the radii are all equal on every circle. So from the center to A to the center to B, those are the same measurement. So I'm going to take 180 minus 138 because this triangle will add up to 180 degrees, and that is going to give me 42 degrees left for angles A and B. Since it's isosceles, those angles are the same, so I'm going to divide that by 2. 42 divided by 2 gives me 21 degrees for, let me erase. 21 degrees for the measure of angle BAC. Okay, on to number 4. For number 4, I have the inscribed angle marked 2x plus 1 and its intercepted arc marked 98 degrees. So 1/2 of 98 will give me 2x plus 1. Half of 98 is 49, and solve for x, subtract 1 from both sides. I have 48 equals 2x. Divide by 2 on both sides, and x is equal to 24. Okay, number 5 is really easy because CE is a diameter of circle Q, and that means that this angle 3 is inscribed in a semicircle or a half circle. So we have a conjecture that says that all inscribed angles that are inscribed in a semicircle are 90 degrees. So as long as you remember that, you can know the measure of that angle is 90 degrees. All right, for number 6, we're going to start by finding the measurement of angle, well, the arc marked Z looks pretty easy to find. This arc is double the measurement of its inscribed angle, so that's 43 times 2 gives us 86. And since we have this arc marked 110, that is going to be equal to the central angle because this angle that intercepts it has its vertex on the center of the circle. So that is exactly 110 degrees. So since I have an isosceles triangle here, I'm going to take 180 minus 110, which gives me 70, and 70 divided by 2, since those two angles are equal on an isosceles triangle, is 35 degrees for x. Now last, to find the measurement of angle y forms a linear pair with the angle marked 110. So if I take 180 minus 110, I get 70 degrees for angle y. All right, number 7. The entire circle adds up to 360. So if I take 153 plus, I'm not writing very well, 79, I get a total of 232. Okay, so 232 is what this arc plus this arc add up to. If I take that away from 360, 360 minus 232 gives me 128 left over for the two remaining arcs that are between the parallel lines. Those are the same. We have a conjecture that says they're the same. So 128 divided by 2 will give me 64 degrees for C and the other one that is marked that's equivalent to it. Okay, on to the back of the review. On number 8, I can see I have a right triangle. I can use Pythagorean theorem to find the measure of x. The radius right here is marked 6, so I'm going to know that the radius is 6 over here also. So the entire hypotenuse of that is going to be 10 units long. So 6 squared plus, that's supposed to be a square, plus x squared will equal 10 squared. And solving that, 36 plus x squared equals 100. Subtract 36 from both sides, x squared equals 64. And then take the square root on both sides. The square root of 64 is 8, so that means x is equal to 8. Or you might have remembered the Pythagorean triple, that a 6, 8, 10 triangle always is a perfect right triangle. For problem number 9, we have to use the conjecture that says any pair of tangent segments drawn from a single point outside the circle are equal to each other. So if this side is 3, then down here is also 3. And if this segment is 5, down here is also 5. So if I take 3 plus 5, I can get the measurement for this side x to be 8. On number 10, it says a chord is 5 centimeters from the center of a circle. So, if I draw a chord on my circle, the measurement from the center perpendicular to the chord is the way we would measure that distance, and that is 5 centimeters away. The radius of the circle is 13. So if I were to connect from the center to the end point of that chord, I would get 13. Find the length of the chord. Well, I've formed a right triangle here, and if I let the leg of my right triangle right here be x, I can find that missing side using Pythagorean theorem. 5 squared plus x squared equals 13 squared. The problem with that is that's only going to give me half the length of my chord, because that perpendicular segment from the center to the chord bisects the chord, so it divides it into 2 congruent parts. So once I get my answer for x, I'll have to double it to get the measurement for the actual whole chord length. So I have 25 plus x squared equals 169. Subtract 25 from both sides, x squared equals 144. Take the square root on both sides, x equals 12. And again, that's not the answer to the problem, because x is also the distance from this perpendicular segment to the other end point of the chord, so I have to multiply this times 2 to get the answer, which is 24. Alright, number 11. This is called a cyclic quadrilateral because it is a quadrilateral with all 4 vertices lying on a circle. We have a conjecture that says the opposite angles, which are those that are not touching each other, they are across from each other, are supplementary, which means they add up to 180. So to find the measure for E, I take 180 minus 123, and that will give me 57 degrees for the measurement for E. Okay. Now, number 12. Number 12 has a lot of parts that we have to figure out. It might be helpful to go through and kind of mark what it is that we need to find out. We have to find AC, which means the distance from point A to point C. We also have to find the measurement of arc DF. So from here to here we have to find. We have to find the measurement for arc HG, which is over here. We have to find the radius of circle P, which we can draw a radius in several different places on here. And then we have to find the distance from point Z to point P and from Y to E. So I'm going to start by noticing the congruent segments that are marked. I'm going to go ahead and put a 12 over here since this one is 12 at the top between P and X, so that means from P to Y will also be 12. And I see that I have a segment YD marked 5 here. So if I connect from P to D, I've created a radius of the circle, and also I have a right triangle that I can use Pythagorean theorem to find that radius. So you might remember the Pythagorean triple, a 5, 12, what kind of triangle? 5 squared plus 12 squared equals r squared. So 25 plus 144 equals r squared. So 169 equals r squared, and the square root of 169 will equal r, which is 13. So the radius of the circle is r equals 13. Now, I need to find some... Oh, well, if I know that the radius is 13, from P to E is also 13. So this little part down here from Y to E has to only equal 1, because 12 plus 1 would give me the full radius of 13. So YE is 1. And let's see, there's some more radius stuff here. From P to H is 13. So 13 minus 8 will give me PZ. So 13 minus 8 is 5. So PZ would just be, or ZP is 5. Okay. Let's find some angles. I'm given this 23-degree angle on this arc, and this is a central angle. Oops. Going back. I clicked a button I wasn't supposed to. From B to C, this arc is 23. That central angle will also be 23 degrees. Now, because I have these right angles over here, I have a 90-degree angle right here. And from G to P to C makes a diameter of the circle, so that has to add up to 180. So if I take my 90-degree angle and add my 23-degree angle, I get 113 degrees, and 180 minus 113 will give me 67 degrees right here for HPG. That is a central angle, so its intercepted arc is equal to that. So arc HG, which we had to find, will measure 67 degrees. Okay, now we need to find the measurement for arc DF. Since I have a 5, 12, 13 triangle here, and I also have a 13 and a 12 right triangle right here, this side will be 5, just like this. These are congruent triangles, which means that these angles are also congruent. So this is a 23-degree angle here, which means the intercepted arc from D to E will also be 23 degrees. So from D to E is 23, that means from E to F is also 23 degrees. If I add those together, I get 46 degrees for the measurement of arc DF. Now all I have left to find is AC. Since I already figured out from X to C is 5, and I know that the perpendicular from the center to a chord will bisect that chord, AX must also be 5, and 5 plus 5 gives me 10 for AC. So number 12 had a lot going on there. Now, for number 13, we're doing arc length, and we solve arc length problems by using a proportion. We set up our proportion. We're trying to find the length from X to Y along the circle. So we're going to say the degrees of that angle, which the angle measurement is 72, because the central angle equals its intercepted arc. 72 degrees out of the full circle, 360 degrees, is going to equal whatever our arc length is, which is what we're trying to find, out of the full circumference. And the circumference can be found by using circumference equals 2 pi r. And we know the radius is 50. So 2 times 50 is 100. So 100 pi. And now I just cross multiply to solve for x. So 72 times 100 pi will give me 7200 pi. And 360x on the other side. If I divide by 360 on both sides, I get 20 pi equals x. So the arc length is 20 pi. And now for the last problem, I have that the length of arc EF is 10 pi, so I was given the arc length this time, and I'm trying to find what the radius is. I'm still going to set up the same proportion. The degrees of the central angle, which is 30 for this problem, out of the degrees for the whole circle, which is 360 degrees, will equal the arc length, which was given 10 pi, out of the circumference of the circle, which is 2 pi r. We don't know r, that's what we're trying to find. So we're going to cross multiply to solve for r. So I'm going to have 60 pi r equals 3600 pi. And I'm going to divide both sides by 60 pi to get r by itself. So r equals 60. So pi's cancel out, and I have 3600 divided by 60. So the radius is 60. To further prepare for your test, you may want to go over your notes, your conjectures, your vocabulary, and any other graded work, homework, or quizzes that you have, and make sure you go in for tutorials if there were any problems you didn't understand in class or on your homework. Good luck studying for your test. I hope you make a great grade. Bye.